Alright, it's fix-it time on Diggy's Do's. I've got these Makita batteries for my Makita tools, and I bought one of these which allows me to plug in a battery and power up whatever I want. But it's not fused. I've already cut the ends of these two wires off, but when I had the battery in here, these two wires came in contact with each other. Big spark, and this battery doesn't work anymore, and I am guessing that there is a fuse inside here that needs to be replaced. So it's time to take this battery apart and see what's going on. The battery is held together by 4 screws, and they are security bit Torx screws. I do not know why they call them security bits, because all you have to do is go out and buy a Torx with a hole in the middle of it. And I don't remember which size, so I had to go out and buy these. I think it's a T10. Yes, here we go. If we get a look on that, I don't know if the lighting is going to pick it up, but that is a T10 Torx screw. I looked at reviews on Amazon, and many bad reviews, because apparently the cheap ones you can get on Amazon don't have hardened tips and they wear out very fast. So we've got 4 Torx screws. If we can see that in the light, this one has a plug in there. That plug is going to be so Makita knows if you ever took the battery apart. And to get that plug out of there, we're going to try something. I've got a just plain old everyday wood screw. We're going to see if screwing that into the piece of plastic will pull it out. If I can hold it steady. Got to get it started. I might have to drill a small hole into that just to get the screw started. Well, we can't get the screw started, so I need to go dig myself up a drill bit. Be right back. We've got the drills. Pick one just the right size for this screw. That should do it. Really need a vise to hold this battery in place. Yeah, that did not do what I was hoping it was going to. Oh, it did. There we go. We got the little plastic plug out. Now, I caution when working with batteries of any type. A battery is a live power source that cannot be disconnected. So once I am in here, I've got to be very careful with what I touch, and we don't want to short out the batteries. And before we get in here, I want to show you that, yes, it does think the batteries are good. So carefully, let's pull the cover off. A little spring here. We have to be careful not to lose the spring. And looking at this board, let's get close up. Here we've got two components labeled 50A, and I'm going to assume those are fuses. 50 amp fuses, that's a lot of current. We've got what appears to be a solder bridge there, not certain with this little bubble, it's probably soldering through to this component. But now we've got to get the meters out and see if these two fuses are in fact fuses and if they're both open circuits. Okay, I've already taken a tour around the board and I've determined, you see I've marked this one B+, this one I marked B-, and we see we've got 19 volts across here. This is output, I've got 0 there. I have a capacitor discharging. I don't know what that's about. It's not a very big capacitor because the voltmeter is discharging it pretty quick. So we've got a capacitor across there. And we switch to ohms and we'll see we've got a closed circuit here indicating this is the B- terminal connected directly to B-. This will be the B+ terminal and we have an open circuit. Testing to what I suspect are the fuses. First we've got this big post here and we've got a short circuit indicating this is soldered to that. And we go to each of the fuses and or what I suspect to be fuses and we see both of these terminals are connected here. But we go to the other side and we have an open circuit, making me believe that these are two fuses that have burned out. I don't know why they're two fuses, but are the fuses connected to these terminals? I'm switching sides because this has got a nice sharp point on it so I can poke right into the fuse. That fuse is connected to here. We come to the other side. It is also connected here. Not certain what these two smaller ones are for. Might be for the charging circuit. So everything's indicating both of these fuses are connected in parallel, which means this should be a short circuit, continuity, both sides, and carefully going to the other side. I have to be very careful these probes don't touch anything else. Going to the other side, and yes, those are connected together. So it appears as though these two are fuses, and now we're going to see if we can get those replaced. Normally, I would be using my hot air gun to pull components off the board, but it is generally accepted you don't want to heat up lithium-ion batteries, which is directly under the PC board. This is a battery right there, and we got another battery right here. Although they appear to be in a plastic case, we don't want to melt any of the plastic either. So we're going to have to try to do this by direct soldering. I need to get my soldering iron over here so I don't have to reach around the camera tripod. Let's get the drill out of the way. I'm not going to need the screwdriver. Make sure the tip is nice, clean, and hot. See how well this goes. Sometimes I find it better to transfer a little bit of solder to help the heat transfer onto the board. Doesn't seem to want to let go. I'm going to need to get my magnifying glass in the way here for just a bit. See what's going on down here. Wondering if they used a high temperature solder. The way that solder is rolling around on this tip, I think this tip is got some issues. And this soldering iron tip has got some serious trouble here. We're going to have to get this. Make sure we're still in the camera view here. Shame on Makita for not making this an easier process. And I need to replace that tip. It's just not transferring heat properly. Got it part of the way up. This one on the back side is going to be much more difficult to get heat transferred.
Woohoo!
This side's free. And now when this one gets hot enough, it'll just fall off. There we go. Yeah, when I get some fuses, I'm going to have to get a new soldering iron tip at the same time. Let's clean up the pad. Now let's see if this other one goes a little easier. Try sucking up the solder off the pad with the braid first. This one's coming up much easier. Then, of course, cleaning up the pads. Being careful not to touch that terminal. Okay, well, let's go find some fuses. Now it's time to find ourselves a fuse. What fuse is this? Doing some measurements. We've got about 6.18. .38. And 4 millimeters tall. I've already looked this up online, and that package case is an SMD 2923, and the markings say it is 50 amps. So now let's go find a replacement. Now it's time to find our resistor. I prefer Mouser Electronics only because I like their search engine. I find it relatively easy to use compared to some others. So to start with, here we're going to circuit protection, fuses. This is a surface mount fuse, which we can find over here. And the criteria that we know, it is a 50 amp fuse, so we're going to select the 50 amp fuse. Down here, I'm only going to want something that is in stock because I want to order it now. So in stock, apply filters, and here's what we have, and here's all of our results. Scrolling down, this appears to be the right size case, and if you'll remember, we're looking for an SMD 2923. Let's move the screen over a bit and see if they'll tell us the case size. There we go, 2923. 1206, 3812, we don't want those. So there's only one in this search group that actually returns what I'm looking for. And it looks like it's manufactured by Burns. So let's take a look at the data sheet. Scroll down, here's our sizes. Height 4 millimeters, exactly what I measured. 5.8 plus or minus 0.3. I measured 6.18, so we're right in that tolerance. And the length 7.3, I measured 7.38, and this is a plus or minus 0.3. So this does appear to be the fuse. So there's the fuse that we're going to order. It is a Burns SF2923HC50C-2. And they're going to cost me $5.35 each. But before I buy it here, what I'm going to end up doing is searching for this part number across some other electronic supply sources to see if I can save a little bit of money. So here's the fuse we selected. So I've actually found some other vendors of this fuse. So let's look at what we've got. Going to Mauser. I've got a total of $18.69. That includes $7.99 UPS ground shipping. That's going to be maybe a week. If I wanted them right away, it would only cost me $2 more. And DigiKey. This is another company I've purchased from. And their shipping's a little cheaper, but their unit cost is significantly higher. So it's a few dollars more. FedEx ground or UPS ground, same price. 3 days, almost over doubles the shipping price. So DigiKey is not the place to go for these parts. But then there was Newark, which I have also purchased from in the past. And they've got a special going. $2.39 each. Shipping is a little bit higher, $9.99, but the total comes to $14.77. And at that price, we're going to order a handful of these guys so that this happens in the future. I will have some fuses available. So now we need to get these ordered and wait for them to get delivered. All right, I finally received my fuses. At least I hope they're the right fuses in the bag here. Finishing the repair on my Makita battery. It's been a couple of weeks. The fuses got lost in UPS and they finally got here yesterday, so we're going to review this real quick to see where we're at. A warning, batteries are a live power source that cannot be turned off, and if during this repair I touch the wrong things, we're going to have some issues. So just refreshing, let's get this voltmeter here. We're looking at what we're going to do. These are the two fuses I removed. They were sitting on these pads. So looking at these pads, and we go over to this side, which is the other side, we see we have 19 volts inside this battery. This is the negative side of the contacts. This is the positive side of the contacts. See, from here to here we have 0 volts, and we switch over to resistance. We can see these two pads are connected to the positive side. This one right here is the battery input. See, I labeled this B+. This is battery positive. And you see going over to battery negative, we've got that 19 volts. And from here to here, we've got 0 on both of those. Switching again back over to resistance. We can see here that this main battery input is connected to these two fuse inputs here. This is the terminal I'm worried about right here. We can see this is part of the battery pack. There are 2 cells between here and here. The lithium ion cells are about 3 volts. So if I've got 7 volts here, there's 2 cells. During this repair, if I short these 2 out with a soldering iron or drop a fuse or anything else across there, I'm going to blow up this battery pack. So let's get prepared and make this a little bit safer to do. Alright, I believe I'm ready to get started. Just standard electrical tape. I've got a standard piece of electrical tape now covering that terminal which I was concerned with. So that doesn't make it perfectly safe, but safe enough for this repair as long as I'm careful. So now let's see if I ordered the correct fuses. That sure looks like them. Let's zoom in and get a close look. I ordered extra just in case I blow up another battery pack, but there's a good chance I'll lose these before I ever need them again, before I take that out of the package. Let's mark the two bad fuses. Don't want to get them mixed up. The markings aren't identical, but the package, as we can see, is the same size. And looking at the underside, we can see that the pads are the same size. So we're good to go with this repair. If you remember, I had some difficulty getting solder to flow on my old tip, and I believe it was because I oxidized the tip and it no longer functioned properly. So when I ordered the fuses, I also ordered some new tips. So let's run over these here real quick. Let's get zoomed in and see what we're looking at. And this is a heavy duty tip, fine screwdriver, or a heavy screwdriver type blade. And these all came in a set, much cheaper than ordering them individually. This one here is a larger screwdriver type tip. Yep, I'm off camera. Here we go. This one is a larger screwdriver type tip for heavy soldering. Here we have a pencil tip for lighter duty soldering. It's very important to use the right tips for whatever job you're doing. Almost lost that one. Here is a needlepoint tip. I use this for surface mount devices. If I was attempting to replace any parts on a PC board like this, I would be using a needlepoint tip for fine control. And the last one in this set is another needlepoint tip, but not as fine as the other one. I will be using this one. As you can see, that is the same as the one that's currently in the iron. So I'll be using this tip for this process. So let's get the soldering iron set up. Here's my soldering iron that I'll be using. I've had it quite a while. I'm fairly certain that that model is obsolete, but I do prefer the Weller brand soldering irons. So let's get back to the workbench. Tip change, pretty simple and straightforward. We just put this one off, put this one in, screw the housing back down, and the new tip is in, ready to go. Now we have to wait and preheat the soldering iron. It's very important not to leave the soldering iron on for extended periods, or you can oxidize that tip. Let's get the camera position a little better. First thing I'm going to be doing is putting some fresh solder on the pads. This is typical solder that you'll see just about anywhere, but when I'm doing some fine work, I use very fine solder. So here you can see the difference between the two. This solder, and here's a look at the label. Oh, we don't have enough light here. Here we go. Here's a look at the label on what solder this is. For this step, I've got my soldering iron set at 700 degrees and now waiting for it to heat up. Let's get our area cleaned up just a little bit. Soldering iron looks like it's ready. What I'm going to do is heat up the pad and apply solder to the pad. Just a very light layer at this point. And that's looking good. Carefully drop the fuse onto the pads. And a quick inspection. I'm going to help positioning this with a toothpick, which does not conduct electricity. Now with fresh solder on the board and holding pressure down on the part carefully without moving it, I'm also adjusted my soldering iron up to 800 degrees. Pressure on the part. This is difficult because the pad is not very big to get heat down onto it. Just waited for it to melt. This one is going to be much more difficult. Especially to do and allow you to see what's going on. See the solder melted. Okay, we've got both pads attached to the board, but not a lot of solder. Okay, that repair is done, we hope. Let's see if we can get close-up views of the board. There's the two new fuses. And take a look at the other side. And now let's see if we have voltages where they're supposed to be. If this is done, I should now have the 19 volts across these two pads. And there we go. Now let's get this battery reassembled and see if it actually works. Time for reassembly. And this was a number 10 security Torx bit. A little hint: when reinstalling screws that are self-tapping plastic screws, when you drop it in, go backwards until you hear a click. That click, that means it has engaged the original threads, and that avoids cutting new threads, which could result in issues in deforming the plastic. So we go backwards, click, and we start it in a little bit. Insert, we go backwards, click, and now we're in the original threads. If you don't do that, multiple removals of the screws will end up destroying the plastic and strip the threads. Checking to make sure everything's, this side's not tightened enough yet. And the battery thinks it's good. Successful repair of a Makita lithium-ion battery.